Hello, everybody. This is Simon McCormack from Drut. Today, I'm going to do a demo of the Llama 3.1 70 billion parameter GPU acceleration using Drut technology. So my story here is that when Llama 3.1 popped on the meta side, I thought I got to use this model and show what we can do with our technology. And I created this demo from that, and I think it's pretty exciting what we'll be able to do today. So I'm going to move into the little picture that shows what we actually have in our setup. So there's a few pieces that I put together. So it's a Llama 3.1 inferencing use case. And I want to show what you can do with Llama with CPU and then adding GPU to accelerate it. And you'll see that in the demo when I'll do it live. So this little box I've drawn here, it's a Dell 74XD 64 core system. And it's using CUDA 12.4, NVIDIA 550 library, Ubuntu 22.04, Llama 3.1, as I said, and I've used this llama.cpp library to be able to actually do it. If there's interest, I can do another session in the future where I actually load all this from scratch, because I've done it a few times. And so you can do this actually on any system with or without a GPU. So you can do this at home, which is fun. I used a lot of guides that I borrowed from the internet, people who've gone before me, so I thank all those guys. All of the guides didn't work because the technology is moving so fast. They'd almost work, but you'd have to figure something out. So mine would be more up to date. So my goals of this is, as I said, I want to do Llama 3.1 inferencing with or without the GPU. And the goals here is you want to own your own AI. So it's all the AI is running on your own software. So we'll show you how to do that. We're going to do it with off-the-shelf servers and software, so anyone can do this. But we're going to demonstrate it with Drut technology, where we dynamically add a GPU to the system. And only we can do this at Drut. So you'll see this live. It's pretty exciting. I'm going to jump to our system now, and we're going to actually move into the demo. So now you see I've jumped onto the system. I've got a couple of consoles, and I've got a Drut software platform up on one of the machines. So my machine number 7 is what I'm doing this on. It's a Dell PowerEdge 740 XD, a bunch of cores, Intel CPU, half a gig of memory. You can do it on a much smaller system. So when I went down this path of trying to determine how to run this, I eventually came on this software package called llama.cpp, which is a C++ library. You have to make it. But for this demo purposes, we kind of needed to go to that level to have the control over the system. First, let me look what's on this system. So I'll go to the node composition for this particular node. See, I've got an offload on that node. I click on that and then go to the chassis. The chassis information. So it's an NVIDIA GPU is on this system. Okay, that's where we're starting. So now if I go to an SSH session on that machine, I can do NVIDIA SMI, and it'll show us the actual model of the GPU that's on it. So it's an L40S. Now I've told you I want to do this without the GPU first, right? And we'll show an acceleration. So the first thing I want to do is actually remove it. So I'll do a detach. This only takes a few seconds as it actually detaches it from the system. And if I run that NVIDIA SMI command again, see there's no supported GPUs. So it's successfully removed it, and NVIDIA just recognized that there's nothing there. Now I want to actually run my model. I'm already in the directory for it, and I'm going to run this command. So it's llama CLI. It's basically a single shot prompt where it'll respond. You can run this as a server, do benchmarks, a whole bunch of options for this library. But I want to do a single shot where I'll ask it a question and it'll respond. And it's pushing this through the CPU. So off it goes. And you notice immediately you see, it doesn't it says I don't have a CUDA driver because it doesn't have a GPU. So nothing's being pushed, but it can answer the question. And you see it's quite slow because it's doing it all in CPU. So if you download Llama 3.1 yourselves and try and do it, you'll find it's actually this 70 billion model that I'm using. It's designed for 8 GPUs. So the advantage of llama.cpp, it allows you to convert and quantize the model so that you can run it on less and run it on CPUs, as I'm doing here. A little slow, but it works. It can also then you can add GPU and run the model on GPU. So it's really nice for this purpose. It's great because it allows you to test and verify how well the models work on different environments and how much you need. You see the slow response is finished. Let's attach back the GPU and we'll investigate that. So I've got my PCIe device, my GPU, and attach it. It only takes a couple of seconds to attach it to the system. It's done it. Now if I go NVIDIA SMI again, it should detect that it's got the GPU. So that quickly, it's got the GPU back. You can't normally do this with standard servers because you'd have to turn the power off, take it out of the rack, and actually physically load it and unload it. So with the disaggregated technology, we can dynamically add it. Let's look at the PCI bus, see what happened there. So LSPCI pipe grep NVIDIA. You'll see there's the NVIDIA device has appeared. And then we can do Drut. So this system has the Drut card in it. Drut card's connected to Photonic Fabric, which is connected to our resource unit where the GPU is residing. We can then detach and repurpose that GPU for another system, which is one of the key values, is the flexibility of how you can use these environments. So the GPU's there. It's going to go back to this, show this here, detected it. And we want to run this same model over here. So this command here, if you can see it on your screens, it's the same command, but I've added a parameter here, ngl81. So this is telling the library to send model layers to the GPU. You could put this 1,000 and it'll send all the layers. I know from experience that the Meta Llama 70 billion has 81 layers. I think the 405 billion has 125 layers. The bigger they are, the more layers, the more memory they require. So in this particular model, you'll see it's a 70B Q4KM. That's the standard recommended quantized size to actually run on a single GPU. So that's what they recommend pushing it down to. And obviously it does actually depend on the GPU for whether it will run it or not. It reduces the precision of the model, but it's a good base level. And that will run fully on one GPU on my L40S. So if I run it now, it goes off. And the first thing it does is it recognizes that it found the GPU and it's offloading layers to the GPU. So if you've got a model that's slightly too big, actually you can slightly reduce the number of layers and make it run on the GPU. So if you've got long-term model runs, longer than this one, because I'm just going to ask it a little question, you see the response, how quickly it comes back. Super fast. And then at the end of it, it reports the tokens. So you see it's the initial one with the CPU, it's 4 tokens per second in the prompt eval, 1 token per second in the eval time, the time it takes to look at the question and actually respond to it. Whereas with the GPU, significantly quicker. I mean, this is 15 times the response time to be able to do that. So it's super quick to be able to do it. So in this case, the advantages of doing this is when you're test and modeling the capabilities of your environment, using this technology makes it very, very easy to do quick test run with GPU to see the speed up that you can get running GPUs on these large language model type environments. So there's a lot of advantage in that in terms of the flexibility of the equipment. The general model we find is that when customers want to use GPUs, or the client or scientists want to use the GPU, they're given a system that has a lot more resources than they necessarily need. So it ends up being a waste. And you have somebody else that needs that system. They don't get to use it because the first scientist is using it, even though it might not be optimized. So this kind of technology, we can much better utilize and optimize the use of the GPUs, which in the long run saves a lot of money and improves the overall return on investment of the technology. Anyway, that's my quick demo for today on GPUs. Put in the comments if you're interested in the full bring up from scratch, because I say I've installed all these libraries a number of times, so it's an interesting process to go through to actually bring it up from scratch on a brand new machine. And I think it might be useful because actually you can do it without the GPU at home on your own Linux-based system. Thanks very much for watching.